Hello, today we are going to analyze an example. Um, Here we have a filter with specification V in 5, R1 and R 1 kilo ohm, C 1 microfarad and L 100 microhenry. I want to analyze this example with AC sweep in the area of frequency and trends in the area of time. I actually place a V scene in my program, then I place a resistor by Control R. By pushing Control R, I can rotate it. Then I type C and place a capacitor. I type L and I place an inductor. Then I type GND earth. I place it in my program. Okay, I can zoom fit by Control W. I connect them to each other. This one, and this. Actually, now I determine the amounts of my elements. For C, I type 0.1 micro. For inductor, I type 100 micro. For resource voltage, I double left click. Then for DC, I type, because we don't have here DC, I type C 0. For AC, as before, set the domain of voltage as 5 is 5. I type 5 for AC and VOF F02. Save attribute. For example, I type 5.2. For frequency, I set 2. TD DF will be on 0. Okay. First, I save my program as filter1, save. Then from setup analysis, I actually set up my settings. The final time will be on 20 milliseconds, no period delay. I don't actually type anything on this part. Step selling will be on 0.1 millisecond. I click on OK, then I go to AC sweep. AC sweep time will be on decade. The points, for example, 10,000. Start frequency from 1. I end the frequency on 10 meg. I click on OK, close. By pushing F11 or clicking on this icon simulate, I go to simulation screen. The program asks me the analyze type should be on AC or transient. Well, I click on AC. Actually, my axis is from 1 Hertz to 10 meg. So here we want to analyze the AC. Actually, here for output, pay attention that the output is R2, C1, or the inductor. Here I consider C1 as my output. I place V C1 from the first side. I click on OK. As you can see, it shows the 0 amount. The reason is that it connected to the earth, so I delete this one, and we see 1 2, which now you see that the output is displayed. This is bandpass filter. Okay, now if I left click on this line, actually I can have a name for this part. For example, out. For example, this part 2, I change its name to out, which is default, which was default, or automatically by double left click I can type in. I click on AC, and from add trace I place V out. As you can see, again the output is like this, or middle pass filter. There is a third way to see the actually amount. I here set a voltage prop. Again I click on simulation, AC, and again the output is bandpass filter. Uh, Here in this part I actually saw the outputs by prop, voltage prop. Here I go to plots, add plot to window, and add trace, V in. As you see, the Vn is constant here. The reason is that the Vin is 5 volt. In the area of frequency, the sinus voltage is constant, because here we're analyzing on frequency area. The sinus voltage is like this. Okay, now if I do the analysis on transient, we want to see that what will happen. I delete the prop. I now do the analysis on transient. Here I click on transient. As you can see, the x-axis is based on time from 0 to 20. I click on add trace. We see one. I click on OK. As you can see, it is constant or 0. We see 1 2. Okay. As you can see, the output is like this. I can see the input 2. I click on add trace. We in. Okay. Now as you can see here, the input is like this, because we're on area of time, we see it as sinus. Add to plot. Now we want to see V in and V out simultaneously. Actually the first one has a 5 volt domain, but the above one has a 6 millivolts. Okay, I have want to zoom this area. As you can see, the wave is not actually straight, and the reason is that the eclipsing, which its amount is high. Here from setup analysis, transient and eclipsing, I change its amount 1.001 milli. I click OK. Then I click on simulation. Transient. I want to see the V out. Click on OK. Now, if I zoom in V out, the output voltage is more accurate. I delete the V out, I choose V in, then I zoom in. As you can see, the V out is a straight sinus. The reason is that we decrease the sepsilink amount. Okay, now if I use a probe here, I place it on V in. Once more I do the analysis. As you can see, immediately it shows the voltage which the probe is measuring. Okay, that's all for today. Thanks for being with us with this episode. We'll hope to have you next episode too. Bye bye.